I'm trying my best, okay? That's all that matters. I am not trying my best, that doesn't matter. How about that?
Yeah.
Yeah, let's put it there. I'll take it there.
See you later.
Yeah, later.
Alright, so a quick minor of the rules of these talks is that there really aren't any rules. They're pretty informal, so if you have any questions, don't be afraid to ask them. Are you going to ask one? Okay. There's a good chance I figure out a question and somebody else is wanting the same thing, and you just want me to go into more detail on a topic, don't be afraid to ask about that as well. So the main idea that most networking is based on is this thing called the OS model, which is a 7-layer stack that basically describes how a network data gets from one peer to the other, starting from the bottom of the physical layer, which just defines your Ethernet cable or your Wi-Fi connection. Up one from there is the data layer, which is about how your router or switch organizes networks on a local address. Above that's network layer, which is where you have your IP address at. That defines how data is transported across the internet. Above that was the transport layer, which defines how connections are made. There's two protocols for that one, TCP and UDP. Session and presentation layers don't really matter all that much, I'll be honest. And then on top is the application layer, which actually is the application that you see, like a website or a remote service or whatever that might be. So, just going to skip layer 1 because it's kind of boring. But on layer 2 is where you have MAC addresses. MAC addresses are related to the MAC that is on Apple computers. It actually stands for Media Access Control, which is a unique identifier that's assigned to every network adapter on the machine. There are 2 to the 48 possible unique addresses, so you have no problems when it comes to running out. Everyone should have a unique one. But they're also only used on a local network. This is in part because they can just be changed or spoofed pretty easily. They're basically just kind of identifying yourself by your MAC address, so if you want to spoof it, you just kind of can. So if you're doing any sort of security based on like MAC address authentication, that's probably not a good idea. The way MAC addresses work is there are 12 hex characters in length. The first 6 are defined by the vendor, where they're assigned to a vendor, and they just give them out as they want, with a serial number at the end, which, since they're identified by the vendor, you can actually, if you have a MAC address, you can look it up and see what vendor it came from, which I'll be knowing later on. Layer 3 is where internet protocol addresses are, which is parts I'm pretty familiar with. These are addresses that are used to send data across the internet through routing. On a local network, they have to be unique if you're doing local IP addresses. On the internet, of course, you have one address for one machine. There are certain allocated IP ranges that are for private ranges that can be repeated, like if you've ever seen a router with an IP address of 1 and 2 to 168.1.1, that's a local IP address, so that's why everyone else's router has the same IP. There are 2 different types of IP. There's IPv4 and IPv6. IPv4 is the one you're probably more familiar with, where it's just 4 octets of numbers that range from 0 to 255. There's, I think that allows for 4 billion unique IPs, which is kind of not enough for everybody. So there's a bit of a risk of running out of IPv4 addresses, which has been slowed down for a bit. That's why we have IPv6, which is a 32 hex character long string, which is not as easy to remember or read. IPv6 is only kind of used, and it's only been kind of used for like, I don't know, 20 years or so. It's supposed to be the future, but we're not coming along on that. IPv4 isn't running out yet, thanks to NATing, which I'll get to later. So netmasks define how many hosts you're able to share on a network. A restricted netmask would be it. Netmask is 255.255.255. It's also called a /32 subnet, which only allows for one host to be on the network. To get to more software devices, you just change your netmask to be something like 255.255.250, which is the most common. This is a /24 subnet, and this allows for 255 to 254 hosts to be assigned. And then you keep going more to /16/8, all the way up to /8 for 16 million or so hosts, which is what you'll be seeing on Iowa State's little networking. So give us a couple examples of netmasks. The first one is internal network Iowa State. This is a private IP range of 10.0.0.1 all the way up to 10.255.255.254. So this again is a /8 subnet. This allows for 16 million hosts so that nobody is running out there. That's why we can have like 6 or 7 different devices on it, so it's never going to be in no danger of running out. So that's their internal network. For their external network, it's between 129.168.6.0.1 and 129.168.6.0.4. This is the /16 subnet, so this gives Iowa State the ability to have 35,000 different hosts on the open internet. The numbers are confusing because it's 129.186, which looks a lot like 192.168. So sometimes you'll look at that and think, well, that's the internal IP address, but it's not. It's confusing. So to give more detail on these private network ranges, there are 3 different network ranges that are defined by RSA 1918 as private. These are the 10.0.0.0/8 subnet, which is shown in the previous slide. Slightly more uncommon one, which is 172.16.0.0/12, so that goes from 172.16.0.0 up to 172.31.4. And then you've probably got the one that you've seen the most if you've done any sort of home networking at all, which is 192.168.0.0/16. This is what allows you to have a device on 192.168.11 or 192.168.0.1 for your home router or something like that. Or if you ever just look at your IP address on your computer, it's probably something in that range. So I talked about earlier how we aren't at risk of running out of IP addresses. There are more than 4 billion devices with internet access probably, but they aren't. There is an issue with sending the IPv4 addresses, and that's through this thing called NAT, which basically allows for you to have internal IP addresses, have them all point to the same gateway or router in this case, and be able to have them all talk to the internet using the same IP address, but be separate machines. The way this works is, from this example, we have 2 hosts inside 1, inside 2. They are given internal IP addresses of 192.168.0.2 and 192.168.0.3. You're talking to the router on 192.168.0.1. The router is looking on the internet at ports 12 or IP 128.1.291, and that's what's talking to the outside internet. So if these 2 inside hosts went to a website like whatismyip.com, they would see that 128.128.129 address pop up, and they're able to both talk to what's on the internet with separate channels going on and have them just do different stuff without the router, like just overlapping channels, stuff like that. So some common protocols we'll be seeing are on the network layer. We talked about IPv4 and IPv6. For transport layer, which is layer 4, there's only 2 there as well. They are TCP and UDP. TCP is connection oriented, which means that every time they try to send a packet back and forth, they will send the packet and then make sure the packet was actually received before sending the next one. That's connection oriented. The other side of that coin would be UDP, which is connectionless. And basically the way UDP works is it just kind of sends packets to the other side in hopes they get there. And if they get lost, then they get lost. So this would be for something like video streaming or online gaming, or the only application on that right side which uses UDP is DNS. DNS is like the address book of the internet. Basically what it does is it translates URLs to IP addresses so that when you want to go to google.com, your computer doesn't know where google.com is. So does the DNS look up for google.com, it finds an IP address and then talks to that IP address. HTTP you're probably familiar with, that's how websites work. FTP is file transfer protocol, that's often used for downloading files. SSH is your shell, so that's a remote access tool that's often used for remote servers. SMTP is how email works, so that's how like Gmail is able to send stuff to Proton Mail by using the same protocol as you. And then the last one is IRC, we're going to go to chat. Not used as much anymore, but still, it will never die, probably. Questions so far, any of that? Yes?
So if you have 2, for the natting router example, if you have 2 devices inside a network that are trying to talk to the same website in the real world, how does the router keep those 2 conversations separate as it's running?
It does. With NAT and magic.
Fair enough. I genuinely don't.
NAT doesn't matter. It just exists.
Is that the official position of IASG?
Yes, we didn't do any sort of NAT configuration ever.
No, it scares me.
Yes.
I'm pretty sure it picks a random port for one host and a random port for the other. And as they go up, it's like, boom, and it comes back in. It works.
But That makes a lot of sense to me. I think that's right. Alright, so can move on to some Linux networking commands that you can run. If you have access to a Linux server in any way, then you can follow along with me. If you're doing a cyber defense competition, you have one Linux server, I believe. So if you want to run those commands on that, that would be good practice. Otherwise, if you have a virtual machine running, if you have a Mac, like maybe the third of these might work. Windows, maybe one. So, main one is ifconfig, which just displays info on the network. It's kind of dumps it all out. This isn't shipped with newer systems anymore. It's deprecated for a different command that we're going to be showing off later, but no, that is way too small. Give me a second here. I should not have unplugged all of that. Okay, so if we run ifconfig, it prints out a ton of stuff. I made the font too big now. So you'll see that I have a couple numbers. This one is hello, this is my loopback address. This is what's localhost is doing, so when you go to localhost browsers, this is kind of the stuff you'll see. Next up you have, I don't know why it has such an ugly name, this is usually called like WLAN 0 on most systems. This is just my wireless connection here. Some main things we're pointing out is you can see that here's my internal IP address of 10.26.191.67. Here's your IP6 address I have. I'm trying to find my MAC address. Okay, here's my MAC address. If you live demos, basically if you search that MAC address on depending website you're just looking at, you'll see that by the first 6 text characters, you can identify where it's coming from. In this case, since it's an Intel processor, it was assigned by Intel, which is kind of cool, I guess. IF up and IF down, these are commands to bring interfaces up and down. This is for if you have a network that's been statically assigned. If it's defined in the file like etc network interfaces or etc sysconfig network scripts for Debian-based and Fedora-based systems respectively. So this is if you want to do maintenance on the network base, you just run IF down, make your changes, and then run IF up right now. It's not if up, it's not if down, which is kind of confusing. Names, running just type like IF down, 0 to bring interface E 0 down, and then IF up E 0 bring back up. So IP Route 2 is kind of a new, I don't want to say networking Swiss Army knife because that term is kind of taken like something else, but it's designed to replace a bunch of these kind of common commands that you would be using, like ifconfig, 2 commands that show, route, and arp, as well as IF up and IF down. So instead of running IF up equals 0, you can instead run IP link set up equals 0, which is somehow better, even though it's like twice as long as IF. The main one that it's used for is IP adder, which is a replacement for ifconfig. I'm going to give you basically the same. Oh, thank you. It's the same output, but it's a different command. They change things like this, I don't know why. Another one you want to use is a series of commands. They all basically accomplish the same job. Dig, NS lookup, and host. These are used to perform DNS queries. So if you wanted to see what IP address website is pointing to, or what website points an IP address, you can just run one of those 3 commands followed by an IP address or host name. So let's go with this one quick. If I do like NS lookup of FBI.gov, we'll see that there are 2 IP addresses that FBI.gov hosts to, as well as one IP6 address. And then you can also go the other way with this by just searching for IP addresses. So if you search for that IP address again, that didn't happen. This worked in practice. Okay, so if you look up 8888, you'll see that it resolves to DNS.Google, which is, yeah, 2 DNS servers as we expected. To get the other 2 commands, you basically do the same thing. So FBI.gov mail server. Those guys want Dig. Dig gives you more data than you ever want. But they all do the same thing for the most part. For network debugging tools, ping and trace are the two most popular. Ping is a good way to just send out an ICMP packet to the server, and if ping is enabled on the server, it'll send a packet back. If you've ever tried to do a connectivity test, you probably pinged like 8888 before. If you try to ping something in ISLab, that won't work with something on the internet. So if you're trying to test anything for the CDC, don't do it right as or if you're computer 230, don't try to ping google.com and say this isn't working, help, because that's to be expected. Google doesn't exist, that's correct. Other command is called trace routes, and basically what this will do is it'll send packets that are supposed to die after 1 or 2 hops, or it'll send packets supposed to die after 1 hop, then after 2 hops, and 3 hops, to map out the path that the packet is taking to get to the remote server. So then we'll use real quick. Ping, you can see ping. Nothing to see there. It replies, sends the packet back in 16, 16 milliseconds. So no trace route. I figure that's gonna happen. Why is trace route 6 installed? Not. I tested this on a different partition, which is why things aren't working, so that is too big. So here's the output trace route. You can see it takes about 11 hops to get to Google, starting with some IO state routers up here, a lot of IO state routers, and then it starts getting to addresses that manage ISPs to get its way all the way to DNS.google. You might have seen a video where a person claims that this is showing you that there are currently 11 people using Google right now, and these are their IP addresses. That is not true. Although that video gets better the more you learn about networking, so I'll post that slide later on. It's fantastic. Alright, last commands are pair commands do the exact same thing. They are netstat and ss. Again, netstat stuff you can use ss now, as they say too. This one's pretty useful. It basically just show you information about listening ports and services on the network. If you just run netstat by itself, it won't give you a very useful output. This is annoying and hard to scroll through and know what I'm looking at. So there's a series of switches that you can use. Most of the time you're running netstat, I think 4 switches or so. The one in the middle is what all, and so if you want to see services that are listening, see the port numbers of services that are listening. Just love that. I lose plant layer on. And T for TCP. It's letters there. You'll see the ports that you got listening on your remote server. So right now this laptop has port 631 listening, and it didn't have anything over here, but that's okay. If you want to see all active connections, then what Jack said is you want to plant. The A shows active connections, so now this shows that there are 3 more connections that are due to Firefox being open. So yeah, there's a good use of there you go. I also didn't include a dash U switch if you want to see UDP connections as well. So there's a lot of courses at Iowa State that are networking based. There's at least probably about half of them maybe. Introductory ones. Computer 230 is the one where you basically just go to network the whole time. So you're learning about that. There, 231s is cousin class in the spring, which is also a good introduction to networking. 252 is the Linux operating systems class. The final third of that class is allegedly about networking. I don't remember it making a whole lot of sense.
The networking in that class has a lot of, at least when I took it, there's a lot of stuff about local networking stuff for setting up firewalls, and the last project does involve setting up a little DNS server and learning how that works. So there's definitely networking stuff in there, and it is like strictly helpful if you're trying to get better at networking things together.
Last class I want to highlight is Computer 430. This is the Doug class about network protocols and security. This is honestly a 400 level class. It's an easy A. So even if you're at the side you don't like go security, I do recommend you take this class, not because it's also just really useful. Beyond that, there are some more 400 and 500, and I think even 600 layer, whatever. Yeah.
Can you explain who Doug is?
Doug is a wonderful man who is in charge of the invest department. I think that's all I need to say. You'll see him at CDCs all the time, making food and pancakes. We're just gonna name Doug foods.
Yes. Doug makes good pancakes and good tacos. If you're signed up to do the CDC, come get the Doug food. And if you're not signed up to do the CDC, sign up for it and come get the Doug food. This is the official position
Yeah.
of the CDC.
I think that's the point I'm going to end on is Doug makes good food. So any other networking related questions you guys might have? Yes.
What are the prereqs for 430, or are there?
I think it's either CompSci 321 or Computer 308. I think you can get that waived. I don't think Doug really cares. He does?
308. That's not right.
At least 308 is one.
308 will definitely get you into it, because that's what I used as the prereq. But I think you are correct, that anybody can approach Doug and say, I would like to take this class, and then if you justify it, they'll sign off on the waiver, and they do it.
You're right. Any other questions? All right, thanks guys.